Now let's look at another example. And greater than or equal to zero constraints. You will see them in most of the questions, but kind of uh, used to for these. You have to be used to for these constraints because these are literally everywhere. So this time we also have this constraint and x plus y constraint. Mm. All right, let's draw the graph and see what happens here. So we don't actually have to draw the first two constraints because we are already used to, and we know the solution would be in the first quadrant, so that's not a problem here. Now the next one is x minus y greater than 1, so we graded it 0. So we graded instead of the greater than sign, so we'll change the inequality to the equal sign to just to find the point. So when x is 0, y is negative 1, and when y is 0, the x is 1. Now again, we just kind of 2, 3, 4 line uh, quickly because we have a limited time. So same on the y-axis, and now we have 0, negative 1, and 1, 0. So it goes like kind of goes like that. So which side do we have? Is it upward side or the downward side? Because the upward side contains the origin. We'll check for the origin and see if it satisfies the inequality. Hence, we replace x and y with 0, common 0. So 0 minus 0 greater than 1. 0 greater than 1 is false. That means the origin is not included and the region is the downward. Next, we have another constraint which said x plus y is less than 2. So let's change the inequality to find the points and make it an equal sign. So after that, when x is 0, y is 2, and when y is 0, x is 2. So 0, comma 2. Let's take this color, too dark. Let's go with this one. Okay, so 0, comma 2 is here. 2, comma. So it's 2, comma 0 and 0, comma 2 would be here. So we'll have equation like that. Kind of like that. So it also has two regions, the upward or the downward. So which one is our answer? We know the origin is now included in the second, the downward region. So let's check for the origin if it's satisfied or not. So 0 plus 0 less than 2. Oh yeah, it's satisfied. It's true. That means the region is the one in the downward direction. So this is the kind of region. Now, if you look closely, you can see a triangle between all of this. So this triangle, this is the combined region. It satisfies the both equations as well as the x greater than 0 and y greater than 0 constraint. So That means we have three corner points here. We already know the first two corner points. These are just the x-intercepts of these two inequalities here, which was 1 comma 0 and 2 comma 0. So these two corner points are here. And now we need to find the third corner point. It is the point where the both equations intersect with each other. So we have to solve them simultaneously. And in order to solve them, we can just replace the inequalities with the equal sign. So x minus y equals to 1 and x plus y equals to 2. Now, or do not go for substitution and any other method. You can simply add the equations and get the answer instantly. So 2x equals to 3, which gives you 1.5. And now you can use this value to find the y. Since x plus y because x minus y equals to 1, uh, x minus y equals to y, and hence 0.5 is equals to y since x is 1.5. So we now have this corner point as well. It's just 1.5 comma 0.5. And now we move to the next step, that is finding the value of function at these corner points. By the way, this one is the bounded common region, so that's why we have all of the corner points and the region is bounded. Alright, well, the value of c when x1 and y0 is 3 minus 0, which is 3. Similarly, 6. And in the last one, 3 times 1.5, 4.5 minus 5 times 0.5 is 2.5. So it simplifies to 2. Now, based on these values, you can easily tell that the middle one is the max value and has 2 comma 0 could be the max point. Similarly, if the question has asked you to find the mean value, you will obviously choose at this point 1.5, 0.5 as the mean point. So I hope now you have a better idea how to solve this question for me. The thing you need is the practice because the more you practice for making graphs quickly, the more you will be able to solve this question in LCAT. So I understand that these are a bit challenging, but with the proper practice and kind of hard work for just these two questions, you can get there.